Ooh, alive. Hello and welcome to Practicalli. Thank you very much for joining me. My name is John Stevenson, and I hope you're going to enjoy my further journeys into learning all things Clojure. This week we're going to have a couple of things for you to look at. So we're going to look at a little bit of spec and generative testing, just to follow on what we've already done in previous videos. And the main thing that we're going to cover today is looking at deploying a Clojure application, a simple server-side ring compojure application in the cloud, using the magic of CircleCI and Heroku. There are other ways to deploy, but this is the chosen weapons I'm using this time. Okay. Oop, I've forgotten how this works now. There we go. Oops, wrong button. There we go. As always, there is all the updates of the work I'm doing and the videos that you can get from Practicalli channel in some nice playlists, so it's easier to find the things that you want. And oh, there we go. And there's also the books. So I've been continuing working on Practicalli Clojure books. There's some more things around generative testing in this book. And I've also added a section on here for today in the Clojure web apps about building a simple web app using Clojure deps.edn project, and using HTTP kit and compojure, and then deploying that via CircleCI onto Heroku. So that's what we'll go through today. And then if you want to reach out to me for any kind of discussions or feedback, or if you want to ask me questions as well, you can also direct message me on the Clojure in Slack. And there's a link to get an account if you don't already have one. And if you don't want to support me, then following me is a good way. I'm trying not to be too obsessive about how many people are subscribing, but I do have over 570 people subscribed to the channel now, so that's great to see. It's great to see that it's of interest to people. And if you want to financially support me as well, that's always much appreciated, and I very much appreciate everybody who's also already kind of contributed to keep me going that way. Okay, so we're going to look at CircleCI and Heroku in the main, but first, before we get to that, then I was working on this banking enclosure project. So we're just going to have a quick recap on this. So this is on CircleCI now as well, so we have got this wired up to the continuous integration service. But this project was is kind of having a test-driven development approach, but also including Clojure spec as well. And so there's a link in here on to the section of the website, which hopefully that's correct. So it kind of explains how I've kind of built step by step the project. And so I'm not going to go through all this, but I'm just going to focus on the kind of running of the generative tests. So this is a deps.edn project. Let's just make that bigger. Oops. And we're going to have that's going to the outline of the design of the project is all these functions are going to write. So currently it's just the ticked sections that have actually been developed. So this is still much work in progress. But I've got some data specifications and a function to register an account holder which uses these data specifications. And this register account holder also has a function specification. And kind of this is the workflow I've been going through. So if we dive into the code of this. Good morning, everybody. Yes. So we've got the requires for this. So it's this is the banking specification. So this is where I've defined all the banking specifications for the project. So this is where pretty much all the specifications are. There is another namespace which I'll get to in a second, but pretty much all the banking specific namespace, banking specific specifications are all in this banking specification namespace. And so this namespace also includes spec and spec gen for the generators, so that can actually generate the generative data and from specifications. Although the specification generators that the generator uses are actually in spec. I found that a little bit strange, but I guess they're related to the specs, so I guess it does make sense. And then there's spec test for doing test check and instrumenting things as well. And then I've included this Practicalli specifications because I've changed the design slightly. So if we go and have a look at the banking specifications, this is a clojure-Commits. This is a CLJC file, so that means it's supposed to be a file that it is a file that the code inside will work for both like a Java environment and a JavaScript environment. So it's kind of a neutral host clojure file, so clojure common. And this just has one spec in it, and the main reason I put it into a separate one is it's quite long, basically it's all the countries of the world, which is just a literal value. So I'm just using a set of strings, and so there's a string for each country in the world, and then that makes that specification a little bit more useful than just using a string, which I had in the first place. So in order to conform to this specification, then the value we test against that specification has to be one of these country names as a string. And then we've got the actual banking enclosure where all the actual business logic is. And I've just included that as a system under test. So we've kind of covered all these in the past one. So I've got all the individual specifications to actually build up a customer details. So the customer's got name, email address, residential address, and social security. I've simplified the email address at the moment because I need a specific generator to actually generate this. I haven't written that yet, so I'm just using email address as a string, which is not a very good specification, but when I get a generator for that, then I'll change that email address to something more specific. And I did the same thing for social security as well. I've just put those as strings because I was using a count, and I'll need a specific generator for those to get reliable results. It will produce a string, but it's not guaranteeing a string of a certain length. So I'll need a generator. I'll need to write a little generator to actually do that as well. So that's something I'll do in a future video. And so we've got customer details, which is basically a composite of all these individual specs. And one thing I did was I found it was really useful to actually have these little sample generators. So if I start my REPL, let's just jack in, and so it's pulling in the test path in there as well. So all the tests are included, and I can go in, and I set it up so I can just go in and evaluate all the specs. So I can just evaluate the entire file, the entire buffer. And it will actually go off, and now I can use these sample expressions, and I put these in a comment block so I can just evaluate these manually, so they don't get evaluated when I evaluate the whole thing, but I can go in and manually evaluate them through the editor or in the REPL itself. So if I just evaluate these, you can see I'm just getting random data generated for me, so I can see that the specification is generating data and it's not causing any issues. One of the reasons I changed the email address was because I was getting issues with generating data from it, and so actually having generators for these is a useful way to check whether you can actually generate data for to test your functions later on. So it's always good to have like the individual specs testing. And I think it's just handy having this code as a REPL experiments, just so you can have an easy way for somebody to come along and see what is actually being generated very, very quickly. And we can also use these in the unit tests as well to generate data for us, mock data. So that's all working. And then one of the things I missed off last time was when I'm defining a spec, I'll need to specify that it's for the function. If it's in a different namespace, then I'll need to give it its fully qualified name. In the design journals I've been doing, then I've been defining a function with defn in the same namespace. In this project, we've got a defn and an fdef in different namespaces. So the fdef uses the alias I've added at the top when I included the banking on clojure namespace. And so this is referring to this other namespace. So if we open this, so this is the banking on clojure. So this is this register account holder, which is in the banking on clojure details. This is our business logic. And the same thing for instrument as well. And then once it's instrumented, so these both are included when I've evaluated the buffer. So it's already got spec and instrumented. So I should be able to evaluate these, and because I'm not sending in the right data, then I'm getting an error. But if I use generate to generate a one specific set of values based on customer details, then it's successful. It passes the spec and returns me a new value. So that's all working. And then we can run spec check. And it's going to generate 1,000 tests. We just do that again so you can see. So here we're generating 1,000 pieces of data that we test with calling the register account holder with by generating a range of data. It's showing us how quickly that's done. And once you've got all your generators that work, then it's actually really fast. I think I was struggling previously with having a slow test check because the specifications I was using, they weren't able to be generated effectively, so it was generating more than it needed to and taking a lot longer. It's taking up to a minute or so. But if you have a longer running check than normal, either you've got a really long specification, or there's some improvements you can make in the generators that you're actually using. So I've got all that running. That's all local. And then I did say I've kind of wired this up to CircleCI. So if you remember from the last week's video, so I did 2 videos of walking through setting up the CircleCI projects, and the second video I did last week was working through a deps.edn clojure project, which is what this is. And if I go and look at the CircleCI in the config, then we've just got so we set it up using OpenJDK and tools deps, so it's using the clojure CLI tools. So that will work for the deps.edn. It's reading in the deps.edn files, and I've changed this to actually use Kaocha. So I was using the Cognitech Labs test runner, and now I'm using Lambda Island's Kaocha. And so the one advantage of this is it also runs, if we're giving it if we give it the right plugin, it'll also run our spec test check for us as well. So it actually runs the test check for us, which is quite nice. So if you go to the terminal, and that's the, where's my other terminal gone? I did have two terminals somewhere. I've lost the terminal window. Where did it go? Okay, I'll create a new one. CD. So we go to projects, clojure, spec, banking on clojure. There it is. So this has got this CircleCI configuration in, and I've basically added a bin script in here as well. So if we go to bin, there is a file in here which just is a simple script just to run Kaocha with the test runner. So I've got an alias, I've got two aliases in my deps.edn, so test and runner Kaocha. So if I look at the deps.edn file, so we've got test, which is adding in the test directory and also the clojure test check library, and then also as well as the Cognitate runner, I've got the runner Kaocha, and I've included this specifically in the project deps.edn because I want to use this alias inside the clojure as the CircleCI build pipeline. So I do have this in my general .clojure.deps.edn project, so it does work for all projects. But when I specifically want to kind of include this into my continuous integration, then I put it into the specific deps.edn file in my project. That way, when I check this in, then CircleCI knows what the alias is and can run it. So this is just adding, this is also adding test as well, so there's a bit of duplication there. But there is the library, and then it's just setting the main namespace to run the Kaocha runner. And if I run Kaocha on the command line, which I did previously, oops, there we go, no, there we go. So I can just run Kaocha. Oops. There we go. So I just run that by itself, and it'll run all my unit tests for me. So it'll do the unit test running. So there's one unit test with a couple of assertions, and that works. But if I also run Kaocha with a plugin, so here I'm just adding a kind of a nice documentation to it. I'm not using random orders for my unit tests because, well, there's only one, so it doesn't really matter. And then I'm using this plugin called spec test check. So if I use this command, then as well as running the unit tests, it should run my generative tests, which it does. Yay! So now we see we've got two tests, because one test is the unit test and one test is the generative test check test it's running. And so now I can kind of build up with confidence both my unit tests and the generative tests, running on the checking the fdefs for my functions, and I can just run Kaocha just to check everything's working just fine. And the final piece of this is to wire all that up into CircleCI. So that's what I did in the CircleCI config. So this is just the CircleCI config YAML file. And so I've added this thing called an orb, which is just a packaged piece of common configuration. So this basically just sets up Kaocha for me, so I don't need to worry about how it's actually configured. You do need to go into org settings in CircleCI and security, and this is not this is like a third-party orb, so it's not one created by CircleCI. So you need to accept that you'll allow CircleCI to run uncertified orbs. But once you do that and add orbs, then I can just include this bin Kaocha script and just run it with the arguments to run the spec test check. And that's it. And then if we go on to CircleCI, then where are we? There we go. Here's my big CircleCI, and this is all I've done. You see, I didn't quite get it right to start with. So I forgot to, if you don't enable third-party orbs, and you get this message saying that you haven't enabled third-party orbs. So it's quite a useful message. And so it was running, so it was successfully running the banking unit tests, and then I added the orb, and then I fixed it, and so it's running these successfully. So we actually look in the build, we actually go and see that we get the same results here. So in this command that we're running, it's downloading all the libs because it's doing this for the first time, and it's, as well as doing the unit tests here, it's also doing the generative tests on this register account holder. And so I've got the same number of tests. So that's working there. So I don't actually have to can manually run the test checks. I can kind of do the test check generative testing as part of the CI if I wanted to, or I can do it locally before I decide to check, or before I decide to do a push. I might do some commits first, and then before I share my code with everybody, it might just be useful to spend a minute just to go and run all the generative tests, because they should take a little bit longer, not much longer. If you've got good generators defined, then it will be pretty quick. But it's useful to do that before you go share your code, and then if you forget to do that, then CircleCI is also doing that for you as well. So very useful, especially if you're going to deploy the application just to run as many checks as you want to. It's very easy for humans to make a mistake. So it's always nice to have a backup, somebody watching, just to make sure there's everything, all the kind of known things are actually working already. Okay, so that's an example of doing generative testing via CircleCI. And now we're going to look at using deploying from CircleCI. So far we've just basically had a workflow where we like spin up the environment, set any environment variables, check in, check out code, download the dependencies, save those dependencies to cache, and then just run the tests. So nothing's really changed there. We're just running extra set of tests by using a different test runner. But if we look at, so let's get rid of this. So we can also push our code to a live environment. So I've got this thing called Heroku, which is a platform as a service. You can just push your code of your application there. It'll build it and deploy it, and you'll have a live running application. And I think I've got it running. Let's see, it's not a very exciting application. I just built the infrastructure rather than the actual content of the application. But you can see it's showing me the build and deployment processes that I'm triggering. And I'm driving these. I could just deploy this straight from my development computer just by doing a git push. I could push changes up to Heroku, and it would just build a new version of my application each time. But since we've got CircleCI set up and it's running all our tests for us, then it's a more kind of safer way of pushing code through CircleCI, doing all the tests, and then getting a Heroku to run, so deploy the application if all the tests succeed. So there are a few steps to this as well. Is it working? There we go. There's my awesome app to be completed. So I'll be building on that. Feel free to kind of build any kind of app on top of this library. So the code is all available here. So all the code is in this status mode. It's a service. Again, it's very simple things, just so you can kind of understand how the mechanisms works. We'll have a walk through that through the rest of the video. So let's kill that now. And when you're using a Heroku, Heroku is really easy to use, although it's set up more for, in terms of Clojure, it's set up for Leiningen builds. So I've got this thing I created about a year ago, which is the game scoreboard, which is just an API. So this is all set up. This is a Leiningen project, and it's in CircleCI. And this kind of works fairly simple. So this is just it's quite an old one. It's using an old version of Leiningen as well, but it pretty much does the same thing. This is just running the tests. But I could add this to Heroku pretty easily just by using the orb. I don't need to do anything extra in this really, because it'll just read the project CLJ file, and it'll pull in all the dependencies and build my application. But when it comes to running clojure.deps files, then there's a little bit more work to do. Let's get rid of that for now. I'll come back to that. Let me close that as well. I'm getting used to closing tabs these days. Yeah, so there's a link in this project, and there's a link in the chats. Yeah, it's Z shell with Presto rather than my Z shell actually in my terminal. Oops, wrong button. Yeah, I'm using Z shell with Presto, and it's using the Power 10K themes to get a fancy prompt there as well. Thanks for asking. And so in the status monitor project, so I've got a link to, did I have a link? I didn't put a link to here. Oh, I should have to add that. So we've got this status monitor. So if you go to Clojure Web Apps book, in the projects, there's a status monitor section, and this walks through building a very simple, purposely simplistic Clojure web app. This will show you just how simple it is, but using the deps.edn approach, so creating a new app. So basically building this from scratch, just using clojure new tool to use the basic app template. And all this means is you can run the project from the command line, which is what we're going to do. We're going to run the when we package up the Clojure project that we're building here, we're just going to run that on the command line. That's what Heroku will do, and have that running and listening to our web requests. So I just created that project, and in the project, then we're just basically adding some dependencies. So all I'm using is, obviously I'm using Clojure, but HTTP kits, which includes a nice application server, and then compojure for doing the routing. And then in the main file, we've got this, which is a status monitor service. Then we've got, we're just including HTTP as the app server, just giving that an alias of app server. And we're specifically including the functions from compojure, because we're just going to use def root and get and probably post in there in further enhancements to this project. Let's look at this code in the editor. So you can walk through here, but it's also in the code in my editor. So let's switch to status monitor. I do have the Leiningen version of this as well, and the deps version on my Practicalli organization in GitHub. So we've got, so the actual system configuration is fairly simple. It is probably the simplest possible, not really a component lifecycle system you can have. Basically, I'm just using an atom to see whether the server is actually running or not, and that's all that's mainly kind of used for. So when I call main, it's going to go in and it's going to run this app server, which has a function called run server, and it's going to latch onto my application, which is called status monitor, and it's just going to run a particular port as well. So this is kind of hard coded; it doesn't need a port to run. I should really pull that from the status from the system environments, to be nicer, and there's improvements you can make around that as well. But essentially, we're starting the application, and we're just basically putting that into the fact that we're calling an application server instance. We're putting that into the Atom. Atom is just a container. Is like a mutable container, but it's managed by Clojure, so only one thing at once can actually change it. So that's why we're just using resets. So when we run main, we just basically run a new instance and put a reference to it in the Atom. And then if we want to stop the server, then we can basically just check to see whether the value is nil. If it's not nil, then we don't need to do anything. Otherwise, we'll just reset the app server to nil, and we send the app server this keyword of timeout, and that will tell HTTP kit server just to shut itself down. So now we can just restart our application server just by doing start and stop. Well, stop and start, obviously the right way around. And so that's a very easy way to actually run it. And so if I run my REPL, so just running a Clojure REPL, and I've included the dev and test sections because I've got some libraries that I just want to run during development and not during testing. So if we have a look at the deps.edn file, so we've got all the compojure files, so all the dependencies like compojure and HTTP kit, and I'm using a few ring libraries as well. So the core ring library, which will help me manage the requests, and so it basically converts all the HTTP requests into so the ring specifications, so the ring maps, response and request maps, and there's some developer helpers. So I should really put this into development, but at the moment my code, the main code, is actually using some of the functions that are in this, so I do need to have that running in production. But for everything else, so things like I've got ring-mock here, which just generates some mock data for us, specifically for testing what we call the handlers functions, so the functions that do something with the request that we've got. So there's a nice little test there. So the way I include that is putting it as an alias dev, and then when I run a dev build of this, then I include that library. But when I'm building something, when I'm building the Uber jar to package it all up, then I'm not running, I'm not including dev in that. So we don't have the any extra libraries that we don't need for production. But I think pretty much, yeah, there's nothing else. There's no other changes in this deps.edn file that's required. What about kill9 syncop? Oh yes, well, yeah, again, there's lots of different ways of starting and stopping things, but I think the way I'm doing the start and stop with the app server is basically just sending this timeout. So it's kind of gracefully shutting down the app server instead of killing it dead. There could be things happening in there, so there's slightly longer running jobs in there. So you can set a specific timeout and it shuts down a little bit more gracefully rather than killing it. I'm not quite sure what kill9 syncop does, if that allows for a timeout or not, but it's nice to kind of not just kill something completely dead. Okay, and then so the status monitor that we're referring to in here is actually the application. And when I'm talking about the application, it's basically the kind of the logic, how to deal with the requests. And so status monitor refers to this def routes, which is what clojure compojure is providing us. So if we go to the compojure core, we've got def routes pulled in there. And this basically allows us to do some very simple routing. Yeah, interesting. I'll have a look at the SIGUPs and see if there's some interesting stuff there as well. I quite like to have clojure controlling kind of things. I'm not quite sure how to do a SIGUP in clojure. So to doing a def routes status monitor, then we've got just a simple routes. So the protocol that it's using, is it a GET request or is it a POST request or some of the other request types you can do, and then the actual address relative to the domain. So here we're just getting the root of the application, and it's going to call a function called dashboard. And so there's only one route that is like a custom route, and then we define a function that is what we call a handler. Basically it handles the request that we get from this. When we do get slash, it handles it and returns, and basically calls the dashboard function, passing in the request object, so request map, as it were. So you can pull information from the request. It's just a clojure map, and it shows you all the it has lots of information there that you can use and customize, and you can add to that as well. But here we're just using the response, so we're using the ring utilities, and that's got a response function, and that basically just returns a response map. So it has all the specific information that you need for a simple response. So if we have a look at the docs here, I covered that when I get start and stop. And so if you've got, if you're having problems with the requests and responses and your handlers, then one of the things you can do is you can debug ring requests. So we've got this handle dump function, which we've included from the ring develop. I don't really want to include this. I'm going to go and take this out the main thing when I develop the project further, but this is quite handy as you're developing, just to have a page that just generates all the details of the request map, and so you can see exactly what's going on. So request map, if we look at the bottom of this page, this is what it's generating. So you can see the request map is a map with all these keys and values in here. So you can kind of see some of the information you can get from the request map. And because it's a clojure map, then it's a lot easier to deal with. There are some nested values in here as well, so you can kind of just walk through the information there, but you can see you can get the remote address, port number, etc., etc., and headers, and passing in session information, things like that as well. There's a body, which is probably more interesting in the response map. And then you've got parameters and root parameters and WebSocket stuff as well. And so you can also add you can get parameters from the URL that you add as well. And the details are also printed out in the REPL when you use this handle dump, so you can get it in both places. So it's quite a useful idea. It's quite a useful tool to help you understand what a ring request map actually looks like. I think I did yeah. And in the reference section of the book, I've also put a new page in that kind of shows you some of the common keys that you actually get inside the response map as well. So this is kind of taken a bit from the pedestal documentation. And once you've kind of got comfortable with the fact that you're just basically taking in a request map, which is a hash map, and then you're just going to generate a response map, which is another clojure hash map. That's essentially all you're doing. You just need to do some logic to get the request map to look to generate the response map that you actually want. So I started off by just basically hard coding the response map in here, but using the response function, then we can kind of do. So we don't have to type this in, and I've replaced this by the dashboard function itself as well. As we're developing the handlers, the functions that are our handlers, and we can test them as well. So we can set up mocking for the handlers. This is a really nice ring-mock library. It's very simple, very easy to use. So this is what I'm adding in my dev section in deps.edn. And essentially I can go into it's like the test version of this and just basically add ring-mock and give it the alias of mock. I've got my software system under test in there as well, so it's got all the functions I'm going to test in there. And I've got a couple of tests here, examples where we're doing tests, and it's basically we're getting it's setting the response to be the sort of the using the app and getting the request, and then we're just checking information in the response map. And there are examples for ring-mock. There's lots of useful things. So you can have you can test for like where are we? Yes. So we can get a mock request, and then we specify the protocol we're using. So whether it's a get or a post, and then the path that we're actually calling as well. So we might want to mock a particular endpoint, the posting to a particular API endpoint, and then we can check to see whether it's we also use mock JSON body, and then we can check to see whether we actually get the results in there as well. So if we go to our code in here, so let's go to test Practicalli, boom. So there's just one test at the moment. So basically using mock request on the get to the root, which is the only kind of business logic route that we've got, and then we're just comparing it to what the body should actually look like. So we've got a status. So this is like the status of the HTTP request, and the body is just here it's just a string. So we could put in HTML. We could also use Hiccup to write a whole bunch of HTML as well. So that's what I'll add later on in this project. And we can specify headers, so the type, like the metadata type of the response as well. So is it plain text? Is it HTML? Is it JSON? So it gives the client that receives the response more information about what it's actually receiving. So I think I've got the test running. Can I run the tests? So I think this is all working. There we go. So I can run the tests. They're all working. I'm running one assertion in one test, and it's running quite nicely. And then I wired it up to CircleCI, which is fairly straightforward. Again, it's pretty much what we've done before. So just create a CircleCI directory, go into config YAML, and so if you ignore this bit, this is an extra bit I've added for the deployment. So just the building and running tests is just this jobs section, and it's pretty much what we've got used to before. We're just defining the image, so we're using OpenJDK 11 and the tools deps image, and then we're basically getting the dependencies. So we're getting the dev dependencies here because we want to run the mock library. We want to include the mock library to run our tests. And this is running our actual tests. So this is just downloading the dependencies, and this is actually doing the tests for us. So we can see we're running Clojure with 3 aliases, one for mock tests, one for the tests themselves, and one for the actual, in this case, it's the Cognitect Labs test runner. So if we go back to here, go back to CircleCI. And so then I added this project to CircleCI, and it's already there. And then, oh, look at all that green stuff. Oh, lovely. And so now we can see that it's building. What's this one? Let's have a look at this one. Oh no, where is it? Where is it? Where? There we go. Build. So this is building, and it was just doing the test runner, and that's fine. So it's running all our tests, no problem. And then we used just like we did with Kaocha, we used a CircleCI orb, which is just, there's a whole bunch of these orbs, which again are just standard pieces of like configuration elements, jobs and commands and executors. So things that are very common in projects, you can just drop them in, and it keeps your CircleCI configuration nice and simple, and also less bugs to actually introduce as well. So there's a whole range of things. So there's AWS, Slack, interesting. So you can kind of do some notifications when you do push like changes through, or do deployments and so on. So we've used this Heroku one, which allows us to deploy an application. So if we go back to, so we've done the testing, we defined the handlers on this already. We set the configuration and just as normal, and to get success. And then now we can just deploy this via continuous integration. So the basic process is that we develop our project locally, we do some commits locally, then we push those commits to GitHub. CircleCI is monitoring the GitHub repository because we've added that repository as a project onto CircleCI. And at the moment we've just got one step just to run the tests, and then it stops. But now we're adding another step. I've got 3 steps here, but we're only adding another 1 step. And then that's going to push the code onto Heroku. I'll push the code changes to Heroku, and then Heroku is going to build that and deploy our application. So to do that, there's quite a few pieces. This is a little bit more involved because because we're not using Leiningen, we are using the clojure-cli tools. Then there's a few extra steps we need to do. So in either case, whether Leiningen or deps.edn, you still need to build a jar file. So in the tools deps, when I created the project, it already had this uberjar alias, which basically uses this little tool called deps.edn, which just builds this uberjar file with a specific name, the name of the project. So it just creates this jar file, which is our packaged Clojure application. And then when we do this, we can run Clojure uberjar on the command line, and it generates our little file, our jar file. So if we go, that's not the right one. Boop, boop, boop. There it is. So we got so we did Clojure uberjar on here, and it's created this jar file, which is just a zip file, so you can actually go in and have a look at it as well. When I generated the file using the CLJ new tool, it created a pom.xml file, which just is some metadata about how the project's organized. So that's already done for us. And because Heroku is using Leiningen, we need to kind of trick it into using our own build script. So we can, which is fairly easy to do. We need to create an empty project.clj file so that Heroku knows that we're actually using that it's a Clojure project and it should use its Clojure build file. However, we could actually just, when we create the application on Heroku, we could actually just tell it to use the Clojure image as well. But this is a way to ensure that it's always going to use the Clojure build process to build and deploy the application. So what we do is we basically add our own build script in the bin directory, and this simply just uses the clojure uberjar command to actually create our uberjar. So just what we've done on the command line. So that's going to build our application for us successfully. It's just one single file, and then we can use that file to actually run the application. And then we need to define how we want to run the application on Heroku. So you do this again, regardless of whether it's a Leiningen or a deps.edn project. You need a proc file, which is the only customization that Heroku really requires is just a file to tell it how to run your application. I mean, sometimes it'll work it out itself, but this specifically tells it, you can tell it exactly how you want to run the application. And this is just the same as you would do on the command line. In this case, we're prefixing this with the kind of web directive because we want this to run and listen to web requests. So this is going to have, so when we run this application, it's going to connect this to the network and going to be listening for web traffic. So it's going to be listening on traffic to on over HTTP or HTTPS. And so the command we're running is the same command we would do to run this application locally. We're doing java jar and just basically running our application directly from the jar. It knows how to do that because it's got the pom.xml file as well. And the only other extra bit is we're adding a port in here as well. So we can't specify the port that we actually want to run in the cloud environment, and this is pretty common for all cloud environments. Especially containerized cloud environments, they will give you a port when they create the container that you're going to put the application in. And so this is just an environment variable we pull from Heroku, and it gives us a particular port that we want to run. And some other tweaks I've made is I want it to run Java 11 rather than Java 8. So the default's on Heroku's Java 8, but I want it to run Java 11. So I've just created a system properties file and just put these simple properties in there as well. And then there's just a few things to configure on Heroku and CircleCI. Again, I'm wanting to run a specific version of Clojure. So that's the same version I've got in my configuration file. So I just go onto my Heroku dashboard and go into the settings for the project, and it will go and set the configuration variables for us. So when you create an application, here I've just gone in to create a new application, and I've created it in the Europe data center, and it's not really, it's only it's quite tiny. It's like 90 megabytes. That's how big my application is. It's quite petite, and that's including the operating system as well, I think. Yeah, so that's quite petite. And when you create an application on Heroku, you get a URL for the code. So you can actually just push the code to this remote repository, and then Heroku would do the build for you. So you can do git push Heroku master if you just add this as a remote. And then I've set the config vars. I don't think there's anything, but if you've got any secrets here that you want to your application to run, then you can add them here, and then you're not checking that code into you're not checking those secrets into the code or into GitHub where somebody could steal them or do something horrible with them. And there's other things you can add here, like SSS certificates and so on. Oh yeah, yeah. So I could actually define the build pack in here as well, rather than including the project.crj file. But that's the only thing, apart from actually creating the project, creating the application in the first place. That's the only thing you need to do. So all I just did was create a new app, and then just give it a name, give it a region, and if there's any specific pipelines I want there as well, then I could do that as well. So that's all you need to do to create an application. And so that just gives you that Git remote that you can push to. And so now all we need to do is just configure CircleCI to go and push to that Heroku Git repository, and then Heroku will build it for us. So then we go into CircleCI configuration, and we're going to use the orb. So basically adding this Heroku orb like we did with the Kaocha orb, and you're going to invoke, it just invokes the Heroku orb, and we specify a particular workflow that uses this orb. So we're going to use Heroku Deploy, which is defined in the Heroku orb, and it's got jobs where we build, and then we kind of do this Heroku Deploy via Git. So basically, the changes we've pushed up to, so we create our let's see, yeah. So we create our changes, we push them up to Git, our GitHub. Then CircleCI goes and builds everything, and if everything works, then it pushes those changes to Heroku, which is the deploy via Git methods. You can also deploy via jar files as well, but I haven't tried that yet. And so the deploy via Git, this requires the build first. So we need to build it first, which is essentially running the tests. And we can specify just to which particular branches we actually want to deploy. So we only want to do this for live. So if we create any additional branches, any feature branches, then we don't want to deploy them until we've checked them into live. And this build means that this workflow will only run after this build job, which is just basically doing our running our tests. So if this job doesn't pass, then this workflow won't run because it requires the successful completion of build. And I think that's it. Oh yeah, and so one other thing, apart from updating the CircleCI config.yaml, then we just need to give it two pieces of information. So the name of the application we've just created, and then your development key, or whoever's account on the Heroku you're actually going to use to do the development. So just make sure that only authorized accounts can actually deploy onto Heroku. And then you just push change. So let's do that now. So let's see. Let's see if we've got oops, Control H. Let's do source, Practicalli, state monitor, dashboard, policy. So do a change, then go into Git and stage the change. Commits, do a absolutely terrible commit message. I don't recommend. Commit that, and I'm just going to push that to the Git repository, which is just my Practicalli repository. So this is just on GitHub. And if I go have a look at, so that's worked. If we go have a look at CircleCI now, oops, wrong one. And we go to service monitor. Now you can see it's running. So that's a good start. This is where it goes hideously wrong with a live demo. So we've got running. So we've just pushed this commit here 8 seconds ago. So you can see it's all live, all real. No smoke and mirrors here. And it's running the build. So this is essentially running our tests. And if that works, then it will run the deploy on Heroku, and we should have a new application. So at the moment, our application just runs a status monitor dashboard. So this is live. You can go and check it yourself if you don't believe me. This is a live URL. So it's just status monitor service.herokuapp.com. And if the CircleCI failed, oh yes, of course it did. I didn't update my tests. I knew it was good. I did it on purpose, honest. This is why I've got a terrible test. Let's see if we do that. Yeah, so my test has failed. Okay, so that shows you that it does actually work. It does catch errors, and obviously I did that completely on purpose. Let's see. Oh dear, so much fun. Let's stage that. Let's commit that. Oops. Bug. That's a terrible commit message. Sorry. Let's commit that and push it. So let's not forget to push that back up to my GitHub repository. Oops, there we go. So typical, yes. So fix the bug now. So it should definitely work. And you can see it has actually worked previously as well. So you can actually go in and have a look at the builds and see if the test did run. And if we go back, oops, where are we? Boom. So that one up. And you can go and have a look at the separate builds because they're separate build jobs. So you can see it's spinning up the environment, preparing the environment variables, installing the CLI. So it's already there. Checking out the code. So this is checking out the latest version of the code from the project, and then it's deploying that to Heroku. So you can actually see the Heroku log of the deployment. And so you can see what it's doing is it's detected this closure application. It's installing Java 11 from our system properties, downloading a bunch of stuff from the internet that needs to run. It's installed the right version of the CLI tools as well. Yay! It's complaining that I don't have a minimum line version, but then I'm not using Leiningen. And there's a big difference between Leiningen 1 and 2, which is, I think that's why the error was in there already. And it's going to install Leiningen, but we don't actually need it. It says building with Leiningen, which is a bit of a lie because it's actually found this bin build. And it's actually running using that instead of the Leiningen invocation. So it's actually running bin build, which is using Clojure 1.1, downloading the dependencies, and compressing the image. So it's just a nice simple image you can just deploy, and then it worked. So let's go back to let's go back to the status monitor. It's still running. There we go. But my tests have run successfully. Yay! So I should write some better tests later on for this project. And so now, because the tests have passed, then it's running the build on Heroku, and we're good. So we can actually see that running as it is. So that looks promising because it's done the same things. It's running the build script, so it should deploy that when it's ready. It's launching. And I can also go onto the command line here. Oh, it's not this command line. There we go. And I can, if it's Heroku, no, not that one. Not that one. Not that one. Where is it? Yeah, there we go. I can also look at the logs as it's doing it from the command line as well. So I've just got a little Heroku command line tool installed. And you can see it's when it was doing another build, it stops the process. It kind of builds, starts a new build, and build success. So it's using the Java jar service, and it's passing in the port. So this is the port that's dynamically generated. So that's passed into the application, and you can see this is a this is the print line statement I've got, debugging statement I've got, which just prints out this message and then gets the port from the argument that's passed to the main file. And so it's picked up the right port, which is nice, and it's gone from starting to up. So if I go to Heroku, I open the app. Yay! I've got a new deployment. There we go. Does it highlight error lines? So I think the logs are quite useful. There's some quite useful colors in the logs, and there is in the actual build here. I'm not sure if it's color coded, but it does highlight issues here. If there's an issue with the build there as well, you will get some messages in there. And from memory, I think they're fairly useful. Depends what kind of issues you're having. You just get like stack traces of things if it's not running the application, or if you get timeouts. If your application doesn't run, it's usually shut down. It's got I think it got about 60 seconds to respond to web requests. And if the application isn't responding to web requests, then Heroku will just shut it down because it believes it's not working. It will set it to status down or status crashed. I think it does retry several times because I had an error where I wasn't using the port correctly, and so it was retrying several times. And there is some examples in here of debugging, so troubleshooting. So if you've got troubleshooting, you can use Heroku logs and then just specify the app, or you can use the tail just to kind of see it live deploying, or any issues that are running while it's any issues you get while it's running, and you get the nice logs generated. One thing I noticed is it doesn't like forced pushes. So if you do a forced push to CircleCI, then it's going to complain that you did it. It can't run the. You've got kind of different commits on Heroku that you have to CircleCI. So I'm not sure if you can get CircleCI to do a force push or not. It's probably not a good idea. So the best way to get around it is to not do any force pushes. Or you can just push. You can do a force push with lease to the Heroku. So if you set up if you do a git remote add Heroku, you can specify you can add the URL for the Heroku git repository, and then just do a push. Because I'm using the live branch, I can do a live to master. Heroku also always deploys from its master branch. And one final thing before we go is I'm using a free service at the moment, and just so I don't use up all my credits, I can try out different applications. Then it's useful to stop the application when you've finished using it. So it's running, it's responding to requests for now. Actually, was it request dump? Oh. Yeah, so it's working, and just to remember to shut it off afterwards. So I'm going to Control C to kill the tail, and I'm going to basically just tell it the processes to stop on the particular application, and it shuts down all my dynos, which are the running containers, and that way it's not using up any of my free credits for the month. And that's it. So we've got that workflow successfully running. and even showing you that if you push bad builds up there, it's not going to deploy because it's got a dependency on building the tests correctly. So you've got a nice little safety net there for your deployment. Cool. I'll have a look, see, I'll do some errors in the, some different errors to see what kind of things actually highlight and see what kind of other troubleshooting stuff I can include in there. But once you get all the infrastructure set up, then you don't need to actually do anything else there. You just need to keep on developing your application. So I think the earlier you do this, the better it is, because then you can not entirely forget it, but you can just kind of rely on that to make sure everything is kind of being tested. And you can also include Kaocha in here as well. So if you've got specifications, you can run that as part of that workflow as well. So that would be, so you'd run the unit tests and specifications, and then it would go off and build your application on Heroku. And then, of course, you can use other things on Heroku. You can use AWS, Google, and lots of other people have services as well. You could also deploy this to, you can just create the assets. You can just actually build the jar files and deploy them to like some kind of asset management, like Artifactory. And so there's a whole bunch of other things you could do and get CircleCI to do that as well. Okay, we're way over time, so I'm going to leave it there. So thank you very much for joining me, and I hope you found that useful. If you've got any more questions on that, please let me know. And there's a whole bunch of extra things we can do around CircleCI. We've just really scratched the surface of this, just the beginnings. So feel free to reach out to me via the contact and feedback on Practicalli or any of the channels on there. And there's lots of other people in this Clojure and Slack community that are happy to help as well. Okay, well, thank you very much, and hopefully see you next time. Goodbye. Oop.